So guys, you should have just learned that when you're talking about forces on objects, you can use something called a free body diagram. Another name for this is a force diagram, and it is a quick sketch of the forces on an object. So I'm going to take you through two examples here. So here we see little Johnny. Little Johnny's just a guy standing there, really happy, not moving around, just standing. Okay, we know that there's a force acting downwards on Johnny, and that is actually the force due to gravity. You guys all know about that. You experience this force all the time. What you might not know is there's a second force acting on Johnny, and this is actually the ground pushing up on Johnny, and we call this one the normal force. And this one comes about because as gravity pulls Johnny down, he is forced onto the ground, and that ground compresses a little bit, and then like a spring will actually push back, and that's where our normal force comes from. So in this case, the two forces are equal in magnitude. Now that means they're equal in size. Each force has the same size, but they're the opposite in direction. So what that means is these two forces will actually not cancel each other out, but the effects of those two forces will cancel each other out. But we can look at a more complex situation. So here we have a car. Again, we've got a force due to gravity acting down on the car. And like what we had with little Johnny, we've got a normal force acting up for the same reason. These two forces, gravity and the normal force, are the same size, but they are in opposite directions. Now that opposite direction is key. But if this car is not stationary, if this car is moving forwards at a particular speed, then you would expect some kind of force actually to make this car move forward. Okay, if you're driving a car, this is the force provided by the engine when you put your foot on the accelerator. You don't need to have it there, but in this example we have it. We also have a force acting backwards. In fact, it's a combination of forces. And these forces are due to friction. That's things like friction with the air as the car passes through the air. You can experience that one if you stick your hand out the window, which I don't recommend, by the way. It is illegal. Stick your hand out of the window of a moving car. The air moving, or as you move through the air will hit your hand, force it backwards. That's actually a friction force. There are other frictional forces, things like the tyres on the road, internal things in the car as well that create frictional forces. So this is just an example of a situation where rather than just gravity and a normal force, we have a driving force and a frictional force. And in this diagram, I've indicated with the size of the arrows that the driving force is the same size as the friction force, but again, they're in opposite directions. So the effects of the driving force is cancelled out by the effects of the frictional forces.